Hello and welcome back to Geometry. Today we will cover guided notes for section 1.4, angle measure. What we will learn today, we will start by skimming the examples for lesson 1.4 and predict two things you think you will learn about angle measures. So let's go through that. Measure and classify angles section. Angles and their angle pair. A real-world example with a map of a high school here. We've got a parking lot, auditorium, and then the library and office. Name angles that have B as a vertex, name sides. We got a lot going on with names. Another name a point on the interior. So it sounds like we've got a lot of naming angles in different ways. So we will learn how to name angles in different ways. Let's see what else we can find. Oh, there's a protractor, classify angles, measure and classify angles. Marked, I'm seeing use a protractor, measure, get 105, okay. So we will use tools and literally measure some things. And then you've got a construction copying an angle. Measure and classify, there it is again, measuring and classifying angles. Now something about bisecting an angle. And that was it. Okay, so only the three examples here, two of them are about measuring and classifying. So that's clearly the second thing we'll learn about is how to measure and classify angles. For our vocabulary section here, we are actually going to match the vocabulary in a way. We already have definitions given. We need to find write the correct term next to each definition. So let's return to the beginning of the section and start reading. Measure and classify angles. A ray is part of a line. It has one endpoint and extends indefinitely in one direction. Rays are named by stating the endpoint first and then any other point on the ray. The ray shown cannot be named as ray OM because O is not the endpoint of the ray. So here's a ray here, goes out that way. O is only in the middle, so I guess you have to start with M. Ray MP, you notice the symbol used there instead of the whole word. Ray MO or ray MO. You got to start with M, you can end with any other letter. Ray, one endpoint extends indefinitely. Let's see if we can find that. Two rays, angle with measure, ray that divides, region, angle. Part of a line with one endpoint and one end that extends forever. Ray. Let's continue reading. If you choose a point on a line, that point determines exactly two rays called opposite rays. Since both rays share a common endpoint, opposite rays are collinear. Here is a line. We have ray JH going that way and ray JK going that way are opposite rays. Let's see if we can find that. Something about being collinear, going opposite directions, extend in two directions. Okay, it doesn't say opposite directions, but it does say two directions from a point on a line. That sounds like opposite rays to me. An angle is formed by two non-collinear rays that have a common endpoint. The rays are called sides of the angle. The common endpoint is the vertex. Lots of vocabulary there to build up our angle. Let's see. Where two rays meet to form an angle. Where the rays meet. I think that's the vertex. Angle with me, a ray that divides, a region, no. Ray that forms, part of an angle, that would be the side. And we got vertex, we got side. We need definition of angle itself. Here we go. Two non-collinear rays, common endpoint. That's the angle itself. When naming angles using three letters, the vertex must be the second of the three letters. So that sounds important. Vertex must be the second. You can name an angle using a single letter only when there is exactly one angle located at that vertex. The angle shown can be named as angle X. Here's the vertex X. Angle YXZ. So if I was to trace that out in order, Y to X to Z, X is in the middle. Or angle ZXY, ZXY, X is in the middle. Or angle 3, because there's the number 3 in there. An angle divides a plane into 3 distinct parts. Points Q, M, and N lie on the angle. So first part is the angle itself. Point S and R lie in the interior of the angle. S and R are the inside. P and O lie on the exterior of the angle. So we've got interior and exterior. Which one looks most enclosed, as it were? Would be the interior. So we need regions of planes. We've got region inside of an angle. That would be the interior. Interior, inside. And now we need region outside. Region outside of an angle. Exterior. There we go. All right, we will go through the examples in more detail in part 2 as usual. But note the study tip, a ray can contain a line segment. The side of an angle could then be a segment. Okay, angles are measured in units called degrees. The degree results from dividing the distance around a circle into 360 parts. So here's 1 degree is 1/360th of a turn around a circle. Okay, degree, unit of angle, where angle is measured more than, I see degrees in the definitions. Ray that divides, angle with measure. Here we go. I had it the whole time. Units used to measure angles, degrees. To measure an angle, you can use a protractor. Angle DEF below is a 50 degree, or note the symbol for degree there, the small circle in the corner. We say that the degree measure of angle DEF is 50, or measure of angle DEF equals 50. Please be aware that degree is not the only possible unit for measuring an angle, but it is the most common and the one we will use in this class. So here's our example protractor with angle DEF drawn in. Place the protractor with the center point on the vertex of the angle. Protractor has 2 scales running from 0 to 180 in opposite directions. Here's a 0 to 180 on the outside, and then 0 starting here on the inside. Since ray ED is aligned with the 0 on the inner scale, we use the inner scale to find that angle EF intersects the scale at 50 degrees. So always measure using whichever side lines up on the 0. Align the 0 on either side of the scale with one side of the angle. All right, based on that measurement, angles can be classified by their measures as shown below. We have the right angle, acute angle, and obtuse. By definition, a right angle, the measure is exactly 90 degrees. The acute angle, the measure is less than 90 degrees. And the obtuse angle, the measure is greater than 90, but it's still less than 180, or 180 is greater than angle C for an obtuse angle. Why? Well, opposite rays with the same vertex would form a straight angle, well, really a straight line as well. Its measure is exactly 180 degrees. Unless otherwise specified in this book, however, the term angle means a non-straight angle, because a straight angle is also just a line. It's not very interesting. Okay, I need to add those to my list here. Let's find angle with measure of 90 degrees. That is the right angle. Angle with measure greater than 90 is obtuse angle. And angle with measure less than 90 is the acute angle. There's the example for classifying. Watch out, classify before measuring. I thought you based the classification on the measurement, but you could classify an angle before measuring, and it can prevent you from choosing the wrong scale on your protractor. I see. In example 2b, you must decide whether angle LJP measures 75 or 105. Since angle LJP is an obtuse angle, you can reason that the correct measure must be 105, because we can see visually LJP there, that goes past the 90. It is more than we want. Whichever scale reads the larger. Okay, there's measuring angles. Now what about congruent angles? Just as segments that have the same measure are congruent segments, angles that have the same measure are congruent angles. So the definition of congruent here is consistent, same measurement. Just we're measuring with different kinds of units. In the figure, since measure of angle ABC right here, 65, equals the measurement of angle FED right there, also 65, then angle ABC is congruent to angle FED. Matching the numbers of arcs on a figure also indicate congruent angles. Notice they both have one pink arc in there. So angle CBE is congruent to angle DEB. DEB is here with two arcs, and CBE is right here with two arcs. So even though we don't have the actual measurement given, we can see from the diagram matching marks give us congruent angles. You can produce an angle congruent to a given angle using a construction, just like we could copy a segment with our compass and straight edge. It is also possible to copy an angle. I'll let you pause and read through that yourself if you're interested. And now a ray that divides an angle into two congruent angles is called an angle bisector. I think we had segment bisectors before as well. Here's now an angle bisector. If ray YW right here, is the angle bisector of angle XYZ, then point W lies in the interior of angle XYZ. Point W, so notice here is the angle, the smaller region is the interior side. W is in that interior. And we know by definition of bisector, angle XYW is congruent to angle WYZ. These two will be identical. So let's find angle bisector on our list. Last one here, a ray that divides an angle into two congruent angles. And I believe, yes, that is all of the vocabulary. Is that the text? Nope, there's a little more to read. Just as with segments, when a line, segment, or ray divides an angle into smaller angles, the sum of the measures of these smaller angles equals the measure of the largest angle. That sounds important. The sum of the measures of the smaller equals the measure of the larger. So in the figure, the measure of angle XYW plus the measure of angle WYZ equals the measure of angle XYZ. I guess 80 plus 80 would make that a total of 160. Fair enough. And then we could use that to further measure and classify other angles. We'll go through that in part 2. And once again, we can produce the angle bisector of any angle without knowing the measure of the angle with our compass constructions. And that brings us to the check your understanding. That finishes the reading portion. Let's return back to the top and prepare for writing the main idea on the next page. Measure and classify angles. We are going to summarize information below about angles in the graphic organizer below. What graphic organizer? I guess I have to draw it myself. Draw and label an obtuse, acute, and right angle. Okay, well, let's find that from the book for reference, and we'll make our own. Let's see, they start with obtuse first. We do need to label it, so this will be angle A, B, C, nice large interior, and label it obtuse. Then next is an acute. Like so, put a point here, D, E for the vertex, and point F on the other ray, and that will be acute. And then finally, a right angle. How do I know it's exactly a right angle? There's a symbol that means 90 degrees. That's a square in the corner, ideally red if you can manage. There we go. Now I know that this is a right angle. We'll call it angle GHI. Then draw and label one angle that has these three names: angle B, angle ABC, and angle 3. Okay, draw one ray here. Another one. I'll make this obtuse, why not? So ray. Angle B means the vertex must be B, and that is the middle letter anyways. We need 2 more points. A for that ray, C for that ray, and the interior is right here, and we'll call it angle 3. What happened to angles 1 and 2? I don't know. Next, congruent angles. Model a pair of congruent angles. Use a compass and straight edge. We will not be using a compass and straight edge for this, but we will practice drawing a pair of angles that the reader is supposed to understand are identical. We'll have angle, you know what? Let's call this angle 1, and we'll make this one angle 2, as we were wondering what happened to those anyways. And I'm going to put the numbers on the outside here because the way to indicate congruent angles is with identical arcs in the interior of the angle. You could also add a tick mark on that arc as long as they match, or multiple tick marks. So as long as they have the same number of tick marks or the same number of arcs, they are marked as identical. So even if I didn't draw it perfectly, we're going to accept that these are supposed to be perfectly congruent because the marks indicate as such. And so now I know that angle 1 is congruent to angle 2. And to help us remember, let's compare and contrast congruent segments and congruent angles. They both are congruent, and we know that congruence still means they both mean having the same measure. But what's different? But segments are measured in length and angles are measured in, I'm going to say rotation. Or you could say, or parts of circles. Remember, by definition, the degree was 1/360th of a full circle. So how much rotation about the circle? Whereas segments are measured in some type of length, whether that is inches, feet, centimeters, or kilometers. And that will conclude the notes for section 1-4. So long, farewell, enjoy the rest of your day.